everyone. So today we're going to take a look at Newton's ball drop apparatus, one of my favorite demonstrations of the year. I'm disappointed that you don't get to be here live for it, but we'll see if we can make it do. So here it is, the legendary Newton's ball drop apparatus. Now, if you could, while I'm coming over to the screen, take on a nice clean sheet of paper, put a title on it, draw that very simple picture. Because what we're looking at here is simply a spring-loaded trigger. If I hold this off to the side, you can see that one end is going to be sticking out. The other end will be sitting on this platform, and when I pull the trigger, it's going to push on one side and pull out from the other. What do you think? Pretty easy, huh? All right, so my question that I have is a beautiful illustration of motion would be, which ball is going to hit the table first? Hey, don't yell out the answer yet. Let's finish with our picture. So I'm going to have two spheres set up. One on the left, I'm going to label this one ball number 1. Ball number 2, it has the hole in it, which will pull out at the same instant. And what's powering this thing is a spring that's in the middle. Do you have to draw all that? No, you don't really. It's okay. Now, my question is, which ball reaches the table first? Write it down. What we're really looking for here is which one takes a shorter amount of time. Okay? You ready? So, it's either ball number 1, ball number 2, or I'll throw in the same. Ball number 1, ball number 2, or the same. What do you think? Good. All right. I disagree, but fair enough. All right. In my experience, almost everyone in the class, previous classes, dumber classes than you, would have said ball number 1. They would say ball number 1 because when it leaves, it's going to be going faster. And that is true, that it will be going faster, because it will have a velocity that is completely horizontal, where ball number 2 will start off at rest. But some of you are saying ball number 2 will make it to the table first because it's traveling less distance. I say, oh, that's interesting. So its path would go straight down, while path number 1 would be shaped more like that, which we call, a parabola. Good. Anybody think it's the same? Yeah? All right, good, good. A couple of you do. How come? Just because it's not 1 or 2? All right, fair enough. You ready? Put your votes down. Write it down on a piece of paper in ink. No cheating. And I want you to watch both of these spheres when I pull the trigger. This one's going to come out here. This one's going to go straight down. Are you ready? 1, 2. What happened? Did you see it? Which one was it? Could you see it at all? Or is this video just useless? Hey, don't answer that. You might not have been able to see it, but I think what you would have been able to do is to hear it. So what I'd like you to do is to turn the volume up if necessary. I want you to listen. Listen for those balls striking the table. Are you ready? 1. same time, wasn't it? Who had same time? Raise your hand. Nice job. Good. How many of you raised your hand, actually, in your room by yourself? All right. Good. That's right. They take the same amount of time. What can we glean from that? Well, here's what I see. I see that the velocity in the x direction does not affect the time in the air. Let's write that down in words. The velocity in the x direction does not affect the time in the air. What does affect the time in the air? Well, what's the initial velocity of both spheres in the y direction? Yeah, see, that's it right there, isn't it? Ball number 1, in the y direction, the initial velocity is 0. The distance is going to be, well, the height, right? The acceleration is due to gravity. And we could solve for the time. If we look over at ball number 2, in the y direction, the initial velocity, oh yeah, it's 0. The displacement, it's still just negative height. Acceleration, negative 9.8. Wait a minute. These are the same. So in this problem, the time in the air depends solely on the y dimension, direction. What it does mean, one more thing, is that the velocity in the x direction is independent of the velocity in the y direction. I'm standing right in front of this, aren't I? The velocity in the x direction is independent of the velocity in the y direction. That's what that shows me. Which means when we go to solve problems going forward, we are going to have to take into consideration both the x and y directions of motion. All right, I might end there. In a little bit, we have a guest speaker coming. Bob Crowley, my personal physics hero, will be joining us. We'll discuss that in a bit.